Hold on, let me get my beautiful face in focus again. Good enough. All right, welcome back. One last section. So let's talk about minerals around Arizona. That's typically when we mine stuff. It's typically we're mining for minerals. There are a few exceptions to that. Coal, remember, is not a mineral. But that's what we're usually looking for. Now, this is an image of some mine locations around Arizona. Plenty of them. Some of the major mines around Arizona. A lot of these kind of yellow-orange colored triangles and diamonds. These are all copper mines with some maybe additional material there. This black mine is a coal mine up in Cayenta Coal Mine in Navajo County on some of the tribal land. It's actually closed down as of now. There is a little bit of gold as well. These are just some of the major ones. Again, some cement mines, but as well as this red cross, which represents uranium. There's a good deal of uranium in and around the Grand Canyon, and if it were up to some businesses, they would go in and, in fact, there are companies that want to do this and are lobbying Congress to do this, go into the Grand Canyon National Park and essentially rip up the Grand Canyon, destroy the Grand Canyon just so they can mine the uranium. There are companies actively seeking to do that. As of now, thankfully, the government's like, yeah, no. But if there's money to be made, people are going to try. Even destroy some things that we hold near and dear to our hearts and sacred. But again, there's more than just kind of those things, some things you might not think about. Iron, mercury, manganese, tungsten. There's all sorts of stuff to mine. Gypsum, another mineral, some helium as well in some certain places. There's a lot of stuff. But what's interesting to note is like most of your mining is kind of in kind of this central and southern Arizona. Not much up in northern Arizona. There's a geologic reason for that, going back to plate tectonics. Remember the basin and range extension kind of through central and southern Arizona. As this portion of the country was kind of pulled apart, it broke, shifted, things moved up, things moved down. When that happened, a lot of material was brought up or close to the surface. Hence, there's a lot of mining done in this area. Whereas the northern portions of Arizona, along the Colorado Plateau, was not part of that basin and range extension. So just a lot of sedimentary rocks. So there's not a lot of minerals exposed there for mining. Some, yes, but not a lot. One cool, at least I think it's cool once I found this out, mine that's actually really near Estrella Mountain Community College. If you look at the map down here, here's Estrella Mountain Community College. This is Thomas and Dysart, where Estrella Mountain Community College is. Just north of Dysart and Glendale, so Dysart and Glendale, is the Morton Salt Mine. Morton Salt Mine. So the Morton Salt, that's that salt, that salt that you might have at home. It's the kind of navy blue container with the little girl with the umbrella. That's Morton Salt. So it's not, but the interesting thing is the salt is not on the surface. Isn't that interesting? The salt is not on the surface. So where could it be? Well, that salt is actually underground. Pretty interesting, eh? So what you see here is actually kind of interesting. What you see on the surface is not the mine itself. The mine is below ground. So below ground, over 600 meters, which is almost 2,000 some feet, there's a big salt bed underneath this area. And instead of drilling down and sending men or machinery down there to get it out, what they did instead is kind of ingenious, at least I think, is that they drilled a pipe down there and they inject water. Well, water dissolves salt. So now you have this dissolved salt in the water, making it really salty water, and then they suck it back out. So now they put down fresh water, helps to dissolve the salt. Now you have salty water. You suck out the salty water. And what they do is that they put this water in these big pools. Like you can see here, they just dump this salty water in the pool. Now here in Arizona and Phoenix area, as it's warm and the sun hits the water and it's hot outside and the water evaporates, well, the water evaporates away, but what's left behind is the salt itself. And they collect it, start all over again. Pretty cool. At least that's what I think. So yeah, but one issue here is that as you take out the material below ground, you're removing the structure that holds up the ground above it. So how long can they sustain this for? How much salt can they erode away to have this big cavity until something falls in? To be determined, I guess. But in any case, the Morton Salt Factory. And the salt, the mineral name of salt is halite. Halite is the mineral name. Salt is just the common everyday word that we use for it. So the Morton Salt mine in Glendale extracts salt by solution mixing. Pump down fresh water, dissolve the salt. Now it's a solution of salt and water. Suck it back out. Let the water evaporate away. Leaves behind the salt. Kind of cool. This mine alone produces 183 million pounds of salt every year. 183 million pounds of salt every year. Think about how much material is being taken from underground every year. And again, how long can they do that before they've taken out so much that the ground above it just falls down into it? I don't know. Kind of scary if you ask me. This salt is actually not table salt. It's not table grade salt, food grade salt. It's actually used for things like producing chlorine for swimming pools and for water softeners. Some of you, maybe in your garage, you have what's called a water softener. It takes the hard water that we usually have in the Phoenix area and gets rid of some of those minerals in it, so it's more cleaner, more fresh. You know, you have hard water if you look around your shower head and you see all that white stuff. That's calcium and other minerals in the water as it's coming out of your faucet or out of your shower head. It deposits those minerals. It's known as hard water. So what water softeners do is takes those minerals out, so the water coming out of your shower or faucet doesn't have that stuff and you don't get that buildup. The salt here is also used at the Palo Verde nuclear generating plant about 20 miles west of us here in Avondale. The Palo Verde nuclear plant, just off the 10, south of the 10, and you can see it from the highway. Sometimes in the winter months you can see the steam coming from the plant, is the largest nuclear generating plant in the U.S. And we have it right here about 20 miles away. So a good deal of our electricity here in the Phoenix area is generated from that power plant. But it uses water mixed with salt as a coolant. In the process, I won't get too much into it, but in the process of generating electricity from nuclear material, a lot of heat is produced, so some stuff needs to be cooled. You can use fresh water, but actually salty water serves as a better coolant. It just has different chemical properties. So a lot of that salt that's produced here also goes out there to help it being used as a coolant. So here's a cross section of Arizona. If I were to take Arizona and kind of slice it down the middle and then kind of turn it on its side and look at it from the side like the layers of a cake almost, this is what we would see. So we have down here in the Basin and Range Province. So this kind of goes from southern Arizona kind of up to Flagstaff. So Phoenix would be right in this area. And you can see below Phoenix, underneath the Luke Basin, is this halite deposit. Halite salt. So there's a rather large salt deposit, and that's what they're mining out. Flagstaff is up here. You can see a little bit different look underground than under the Basin and Range Province. You see all these faults and this movement of material. Some stuff went up, some stuff went down. But in Flagstaff, outside of the Basin and Range Province on the Colorado Plateau, you don't see that. It's more consistent, but you do see some what looks like igneous volcanic material making its way up, and that's exactly what it is. More on that in a later unit. Let's see, is there anything else I have to say? I don't think so. So, with that being said, let's wrap it up, shall we? All right, touchdown minerals, just a little bit on rocks, more in the next units. Unit 6 on igneous volcanoes and igneous rocks, Unit 7 on sediments and sedimentary rocks, Unit 8 on metamorphism and metamorphic rocks. So we'll take each of those different types of rocks and spend a whole unit on those. So this one was just kind of touching on minerals and how they are connected to rocks. So what are some of those big ideas that we talked about? 5 components to be a mineral. Remember those: natural, inorganic, etc., etc., etc. Mineral characteristics. We'll look at some of these again in lab. So looking at luster, cleavage, streak. Those are some ways that we can figure out and identify minerals. The different types of rocks: igneous, sedimentary, metamorphic rock, the rock cycle, a little bit of how that works. But again, we'll take some time in the next few units to really dive into all of these. And mineral mining around Arizona. Where do we mine stuff? Where are a lot of mines? Where are not a lot of mines? What kind of stuff do we have around Avondale? So those would be some good things to kind of remember. With that being said, it's been my pleasure. It's been my honor. Hope you saw that code. If you are now at this point in the videos and you have nothing for the code, you might want to go back and watch them. Remember, with the videos, watch and listen. You might want to go back and keep your eyes open. All right. Until next time, adios.